Welcome to Boom or Bust Season 1 Episode 8, the show where you design subwoofer enclosures, I 3D print them, and we place them head to head to see whose is the loudest. Now, on today's episode we have what is being called the Fibonacci fourth. Yes, this is a crazy wild looking enclosure that somewhat resembles a turbocharger perhaps, or a snail shell, but this enclosure, by its name, was designed around the Fibonacci sequence. Therefore, the flair of this horn, I guess if you like, was designed based on the sequence. Expansion was based on the sequence of numbers. Now this is a fourth order by the name as well, Fibonacci fourth. So what we have here is a little sealed enclosure with the driver in it. Now this sealed box then gets shoved into the horn mouth, I guess, or the throat and mouth, the horn expansion line here. And the coolest thing about this enclosure is the volume of air that sits before this kind of expanding horn part begins is actually changeable. You can modify it by changing the height of this sealed enclosure, how far it goes into the box. So that is obviously the smallest amount of enclosure space before the horn starts, and that is a larger amount of enclosure space, and I guess that will change the tuning or the resonant frequency that this horn will maybe produce. But honestly, I have no idea what this is going to do, no idea how it's going to perform. This is probably one of those enclosures that's either going to perform absolutely terribly or amazingly. I don't really see this being middle of the road. It's either going to completely wipe the floor with the competition, or it's just going to be a bit weird and not do too well. But that's what we're here to find out. As far as looks goes, I would say it's definitely one of the coolest designs that I've had sent in so far. It just looks really sweet like that, doesn't it? The freaking horn thing coming out there. And I love the fact that this is tunable, that you can change the tuning. I don't know what effect that's going to have, and we're going to test that, but I just love that that is a thing that exists. It's freaking awesome. So naturally, the first thing we're going to do is slap this on the Dayton DATS V2 and see what the heck the impedance graph for this thing looks like. So what do we have here then? Naturally, I pulled the impedance graph with both the sealed chamber at the minimum position and the maximum outward position to see what was different. And these are the two graphs. So this is with it at the minimum position, and with the maximum position, bigger chamber inside, you can see it has changed. It looks very similar, but it's a bit different. If I was to look at these two graphs, I would say that in our testing here for this competition, the maximum outwards position is probably going to perform better. The reason I say that is because we have a bit of a lower tuning frequency. So with the box in the minimum position, right down low, it's tuned up here to about 230 hertz. That is where the impedance dip is the lowest, and that's where the driver will be held onto the most by this fourth order bandpass. Now if we pull the sealed chamber all the way out to give them more volume before this kind of horn bit starts, that tuning frequency drops to around about 210. It's like a little bit lower, but it's still above 200 hertz, and we are testing the minimum frequency at 150, and look what we have nearer to 150. Oh yes, we have a massive impedance spike, and that is going to be, well, the woofer pretty much unloading and going to be moving a lot at that frequency. The biggest impedance spike here on the low side is about 165 hertz. So yeah, kind of similar-ish actually to the Half Wicked one. I know that that had a big impedance spike down at 150, yet it still did amazingly at that frequency. So it doesn't necessarily mean it's not going to be loud at that frequency. It just means the driver is going to be moving a lot. Now the next impedance spike up is at about 285, 290, and that's going to be as a result of the air spring in the sealed chamber ringing in phase with the cone of the driver. So that's going to be aiding its movement. The reflections of the kind of air inside is pushing back on the driver while it's during its outward stroke, therefore it's causing it to move a lot easier. That's also kind of close to another frequency we test, 270. So yeah, it looks like this box has two impedance spikes very close to the bottom two testing frequencies, so I might be limited on power. Obviously I can't see the driver in this box when I'm testing, so I'm going to have to probably remove the sealed chamber, calibrate roughly some sort of power that I can get to before I exceed the mechanical limits of the driver, and assume that it's going to be similar-ish when it's in there and just listen out for it, I guess. Kind of going to be kind of hard to gauge, but I'll, obviously try not to damage the driver here. If we go up from that second impedance spike, there is a third impedance spike. Looks like we have a little baby one here at about 540 hertz there. So it looks like we might be loading either side. And that's probably going to be a quarter wave mode of this horn area here. And we can actually confirm that by just running a DAT sweep on the sealed chamber alone and see what that looks like compared to how it looks in there. So I'll show you that in a moment. But yeah, this is going to be part of the horn lane. We've got one impedance spike here at about, yeah, like I say, 540, 550. Another one up here at about 1100, which is double the frequency of this first spike here, and then another one up here at about 2200. So yeah, this is exactly quarter wave modes, going up and doubling in frequency every time. Now the highest frequency that we test is 360 hertz. So depending on whether there are any modes that this kind of quarter wave resonator can use below this 550, we might not benefit from any quarter wave modes of this box, but this shape should still aid the output from the sealed box alone. It should act as a kind of wave guide in a sense and actually bolster up some of the frequencies that are being emitted by the sealed chamber alone. One thing I find kind of interesting though is if we go back to the minimum position impedance sweep when it's the lowest, you can see that the two impedance spikes on the higher end, so the sort of 1100 and 2200, don't seem to move, but the lower impedance spike does. It shifts up to almost 600 hertz, just a little bit under 600 hertz, but the other two don't really move. So it's possible that this initial little impedance spike at 550, 600 isn't actually part of the quarter wave mode. It could be some Helmholtz ringing or something like that as a result of this bottom chamber. I'm curious to run a little impedance sweep though with just the sealed box and see what that looks like. I imagine we're going to get rid of some of the higher impedance peaks here at sort of 550 and beyond, but I want to see what the air spring in here actually is set to. Huh, you know what, there's actually still a couple of little impedance spikes up at about 1.3 kilohertz and 2.2 kilohertz. Again, I wonder whether that's not actually modes of this bottom chamber. I wonder whether that's some kind of ringing going backwards and forwards between the parallel walls of this little sealed box. So that might not have anything to do with this bottom chamber. Really interesting. So we can see here that the air spring is tuned at pretty much dead on 200 hertz, which is actually kind of cool because when this is shoved in here, 200 hertz becomes, instead of an impedance peak, it pretty much becomes an impedance valley. So that shows that this enclosure might be very potent at that frequency, because if you think about it, if the air spring in the seal box wants to resonate at sort of 200 hertz, and this bottom chamber is holding onto the cone hard at 200 hertz, then the air spring is really going to help to make that loud as hell. But putting this sealed box into here might change the characteristics of the air spring in the sealed box a little bit. It might raise it or lower it slightly, so yeah, I'm not entirely sure. If you have a lot more knowledge about this and how the impedance sweeps are affected by various things going on here, man, drop some info in the comments. Love to be educated, as I'm sure would everyone else. Anyway, I'm sure just like me, you're dying to find out what this thing sounds like, so let's plug it into the amplifier and have a quick listen, see if there's any weird tones or distortions or air chuffing or anything like that going on with this box. Alright then Stephen, what does your box sound like? 25 scaled hertz, this is 150 hertz. It's a bit of a buzz. What is that caused by? It was the bloody tinsel lead slapping on the cone. It was the tinsel lead slapping on the bloody cone. Well, now that's sorted. Okay. That 300 hertz harmonic that we've listened to in other boxes is strong, and that's probably because there's not a great deal of loading on this driver at this lower frequency. So yeah, the wow is very strong. So this is basically 198 hertz, which is 33 scaled, and that's bang on the impedance null. So this might be very loud. Not bad, not quite as potent as I thought it might be, but there's quite a lot of chuffing coming from inside the box. Now there is this kind of archway that the pressure has to kind of go through, and I'm just wondering whether that change of area and size might be causing some chuffing for the air. 45 scaled. The chuffing's still there at that one, but that is quite potent. It sounds quite clean up there though. Yeah, nothing super crazy weird going on apart from that harmonic on the lower end, which we've seen before. But yeah, nothing really super weird apart from the chuffing, which isn't going to affect our results here, but might be a problem if you scale this up. Yeah, so as expected, tons and tons of distortion down there at the 25 scaled hertz being a 150, especially when we push this. Now, while the graph was looking absolutely horrific like this, I was actually only pushing about 6 watts, so barely get any power to the driver at that lower frequency. Might still be loudish in the cabin, but yeah, not super ideal. Next frequency up, the sine wave does clean up and we don't get any crazy harmonics, although the wave is a bit of a weird shape. Look at this, the bottom of the waveform is sharper than the top, and it kind of slopes up steeper on the upward climb and it's more shallow on the downward climb. That's interesting. This shape continues on with the 45 scaled hertz and also on the 60 scaled hertz as well. All of the frequencies have this weird kind of shape to the sine wave, so yeah, this enclosure is definitely doing something interesting to the outputs. Looking at the RTA, you can see, yeah, at 150 hertz there is mountains, all kinds of distortions and harmonics coming in here, especially up at 450. You get less of them on the higher frequencies. This is 33, but still quite a few harmonics compared to some of the other boxes we have seen in this series, where you only get a very small couple of harmonics start to come in at the very top end of the volume level. But yeah, with this one, the 3 or 4 main harmonics above the fundamental are creeping in quite early on. So yeah, pretty interesting. Now, even if this ends up being quite loud, it's worth bearing in mind that it's definitely coloring the sound. It's not reproducing exactly what it's being fed with. The box is adding some distortion to the sine wave. Now, whether you'd be able to hear that in real life if this was scaled up and you were playing low frequencies, I don't know. It might even be a pleasant distortion. People like distortion sometimes. But yeah, worth bearing in mind that even if this is loud, it's not ringing true to the signal it's being fed. The box is modifying the sine wave in one way, shape or form. But now let's do the fun part. Let's listen to some music demos in here and see how it comes out on camera. Now, for anyone new here, when we're playing these music demos, I record them and play the tracks at ×6 speed. So the songs in real life here while I'm recording them sound like, and then I record it in high speed, slow it down by a factor of 6 in Vegas and overlay the high frequencies from the track over the top of it. So the low frequencies that you're listening to when you're watching this video are actually being produced by the driver, picked up by the microphone in my phone. No added distortion or gain or anything is added to the bass notes that you listen to. It's literally just the microphone on my phone being unable to handle 140 dBs of pressure that's actually going on in this chamber. And there's no added camera shake either. It's literally just the fact that my phone ends up resting on one of the chairs here or the roof and it vibrates slightly against the hard surface. So everything you see is absolutely real, just 6 times faster than it's being played back. As for positioning, I think it's fairly obvious that it's gonna probably be loudest pointed right at the back of the cabin like that. Stephen did send in a few diagrams of some suggested positions. I'm going to play around with a couple of them, but I suspect we'll end up firing it towards the back like this, as the Wicked one was loudest like that as well, and that's kind of a similar mouth size here, so it's probably going to be loudest like that as well. seem pretty loud, but it's down to the meter to decide exactly how loud. So as always, we're going to test first with the cabin door open, and we're going to play 25 scaled hertz first, being a 150 in real life. So let's see what this is doing. I'm really excited for this one. Now, I don't know if I can quite go up to the full 15 watts on the watt meter at 25 hertz, because it was unloading quite drastically, but with it being in the horn here and in the cabin, there might be enough load on the cone, just enough for us to reach that 15 watt mark. So let's turn it up and see if we can hear any mechanical limit. If not, we'll go all the way. $15.7. Oh, 145.4. Wow, okay, that is on par with the half wicked one and with my benchmark aeroported box. Wow, alright, so I told you at the start this was either going to be a solid performer or a terrible performer. Looks like we're right at the top of that benchmark. Can it maintain, this is the important bit, can it maintain the high dBs at the upper frequencies to bring the average up with it? 33 scaled hertz now. $15.2. Oh yes. Oh my gosh. A 142.8. This is gonna be, if it can do the higher frequencies, this is gonna be nuts. So 45 scaled, what's it doing? That's only 5 watts. We've still got 10 watts to go. $15.5. Oh, and a 138.4. That's still pretty impressive. I think this is going to be the winner here. And last but not least, 60 scaled hertz, being a 360 in real life. $15.4 and a 132.9. Whew, okay, yeah, I mean, I can't remember the exact scores of the wicked one, but this seems pretty up there. Let's seal off the cabin and run those frequencies one more time with the door closed. We're usually much lower across the board, so let's see. 15.6 and a 138.7. Oh. 15.6 and a 139.2 with the door closed. 15.1, 132.7, 126.9. That's the lowest one so far. So working those out for an average gives us a 139.88 dBs with the door open, and with the door closed a 134.38, placing the Fibonacci fourth in first place, knocking the half wicked one off its crown with the door open at least, but with the door closed, the half wicked one still just has the edge. The difference is about 0.3, 0.4 dBs either way, with the door open with the Fibonacci fourth being in the lead and the door closed with the wicked one being in the lead. And as I've said before, this can just be differences in the actual sizes of the boxes in the chamber here, and one specific positioning or size might prefer with the door closed versus the door open. There will be slight differences with that. That means on the leaderboard now we've completely lost the neuter shooter. It's gone off the bottom into bus status, and my benchmark aeroport on the door closed side has also made its way into bust status, with the base barrel as well in bust status already with the door open. What I find kind of interesting is the two enclosures that have performed the best so far have the biggest kind of opening from the enclosure. So you see how the Fibonacci fourth and the half wicked one have very similar like final mouth sizes here, and the loudest that we found in this test cabin was to push this pretty right up close against the back wall. It wasn't like very close, it's probably like maybe 2 or 3 centimeters, maybe 4 centimeters away from the back wall. So that might in itself have a great benefit over just what the enclosure is capable of, and obviously having a big mouth there might affect that in some way, versus having, for example, just an aero port that's not pushed right up against the back wall. I mean, I'm quite impressed with these. I mean, this my benchmark aero ported box. There's a tiny little aero port there, and it wasn't pushed right up against the back wall. It was kind of firing to the side, and it also managed to 145 dBs at the lower frequency, albeit it didn't do well on the higher frequencies, but that could be something to do with it being up against the back wall here, using this kind of like loading off the back wall to make the higher frequencies come through more potently, or improve the lower frequency by extending the effective length of this horn thing. Yeah, I don't know. But either way, the designs that seem to be performing best are the ones that have a nice big kind of mouth opening into the cabin here. I'm a bit surprised that the T-line that Justin made didn't perform better than it did. Like in the demo clips, it definitely looked extremely loud, one of the loudest looking ones we've had so far. And it has a relatively big mouth area here, and I think we had it pushed up pretty close to the back wall there, but yeah, just was quite a bit off the mark. We were like 4 dBs off of the half wicked one and the Fibonacci fourth. So yeah, despite maybe not sounding very nice based on the scope waveform, it's certainly loud across the whole frequency range in this test cabin. Doesn't necessarily mean it will translate to different shaped vehicle cabins very well. Maybe if the back of the cabin was sloped more like a hatchback, where you couldn't push it right up against the flat back wall, maybe it wouldn't perform quite as well, and some of the other boxes would then come up in performance compared to these ones with larger mouths. Not sure, but that's something we can look at in a future season. Maybe season 2 or season 3 will change the shape of the test cabin, have it be more like a slanted back. Yeah, we'll see how it goes. But for now at least, in boom status number 1 throne position, we have the Fibonacci fourth, and the door closed, the half wicked one is still in top spot. If you think that you can design an enclosure that gives us a 140 dB average across the range, we're so close, 139.8, that's very close to a 140 average. If you think you can do it, then by all means, design something on 3D CAD, export it as an STL file, send it in. All the details that you need, all the instructions for the dimensions, the tuning frequencies, everything, TS parameters of the driver are all in a document in the description. So go check that out if you want to have a go at designing something that you think can dethrone the Fibonacci fourth and the half wicked one, and maybe squeeze out a 140 dB average across the range. If you're keen on sponsoring this series somehow, maybe either with a logo on the test cabin or a sponsored segment or message in these episodes, then feel free to get in touch as well. There is an email in the video description. But yeah, this was a pretty exciting one. I'm happy with how it turned out. Like I said, I thought it was going to either perform amazingly or perform terribly. So give this a thumbs up if you're enjoying it. Feel free to subscribe as well. Like, I'm not super fussed about subscriber numbers. Doesn't really mean a lot today in YouTube. It just looks cool, and I'm getting closer to the 100k. I mean, I was 67 or something. I've had my channel since 2006, so it's a very slow growing channel. But I'm hoping that this series will hope to boost my channel a little bit and get some of you guys over on board and enjoying the content. So yeah, take it easy guys, and I'll see you probably on Wednesday. I'm trying to do these 2 times a week now, one on a Wednesday and one on a Sunday, so see how it goes. Have a great evening, and I'll see you next time.